Hi everybody, this assignment is really designed to improve your quantitative literacy skills, your data analysis skills. And you can press pause and read what that means here. And we're going to go through many of the quantitative literacy goals throughout this assignment. Okay, and so as we analyze our data, we're going to represent, we're going to analyze, we're going to make assumptions, and we're going to suggest improvements and acknowledge limitations. Okay, so what we have are years from 1965 to 1940, and then median sale price of houses in the US. Now, first of all, what does median mean? Median is a type of average, and it means that half of the houses sold were sold for less than that number. Half of the houses sold were sold for more than that number. So that means in 1965, half of the houses sold in the country were sold for less than 20,000, so it could have been 5,000 or 10,000 or 15,000 or whatever, and half of them were sold for more than 20,000, so like 30,000, 45,000, 22,000, whatever, right? 2020 though, half of the houses in the country were sold for less than 330,000, and half were sold then for more than 329,000, right? 330, whatever. So half of the houses were, 200,000, 300, 310, 245, lower than that, and half were more, like 330, 340, 500,000, a million, right? Okay. So that's what median means. Now, we're going to see if we can come up with some sort of a pattern here. Let's start out by seeing, can we see if there's some sort of linear growth? Like, our house price is going up by a set amount every 5-year period, right? So what we're going to do is click on this cell C3. Click here, right? Perhaps I should zoom in. So we're going to type equals, the equals sign. When you type equals into Excel, it makes a calculation, okay? We're going to take this number and subtract this number to see how much prices increased from 1965 to 1970. But instead of typing in 23,900, we're just going to type the cell number, and that is cell B3. And if you just click on it, it'll automatically type B3 for you, right? And then we hit subtract. I'm going to subtract cell B2. So the column is B, the row is 2. And so that's cell B2. So click on it. And now just press enter. And it automatically subtracts. And what does this number mean? This number means that house prices on average increased by $3,700 from 1965 to 1970, right? And then we can keep going down the line and doing that. I'll just do one more for fun. Equals B4, this number, minus this number. Press enter. So from 1970 to 1975, median house prices increased by $14,000, right? And we can keep going. But I want you to learn an Excel trick, an autofill feature, okay? So we click on, well, actually, I don't even need that one. We can click on this cell and go to the bottom right until you see the little black cross. And you hold your left click down and you just drag all the way down and then release, okay? I'm going to do that again. So what you're doing is you're holding the left click on the mouse and you're dragging down and then you release. Okay, so find the little black cross in the bottom right, hold down, left click, drag down and release, and it fills it all in for you, right? So you don't have to individually calculate everything, right? Now, can we see a pattern? Are the house prices increasing by some same amount or even a similar amount every 5 years? Is there any pattern here? See a pattern? Press pause if you need to think about it a bit more. Well, I don't see a pattern at all. This is fluctuating. This is volatile. They usually go up, but they go up in different amounts. Sometimes they've gone down, in fact, right? So I see prices go up, but they fluctuate. Sometimes it's up by a lot, sometimes it's up by a little, right? That's what I see. Now let's see if there's some sort of an exponential growth pattern, like a regular percentage change each 5 years. So I'm going to go equals. And remember, when you get percentage change, you take the change over the original. Whatever it changed, the increase over the original or the decrease over the original. So I'm going to go equals and then this over, that was the increase over the original 1965, which was 20,200. So if I take this increase and divide by original, that'll give me the percentage change from 1965 to 1970. Press enter. 18%. Okay. House prices went from this amount to this amount. That was the increased amount, the 3,700, and that's 18% of 20,200, right? And just for fun, if I went like equals, 18%, 0.18 times, 20,200, that would give me about 3,700, right? This is rounded, right? So that's the 18% increase. Now we could do it for all the way down. We can go equals this number, the change, over the original from 1970, which is this. So from 1970 to 1975, houses increased by $14,000. They began at 23,900. And so if I put the increase over the original, I get my percentage change, 59%, a huge increase from 1970 to 1975. Massive. And so on and so forth. You can do that, but the best thing is use the autofill feature on Excel. Click here, go to the bottom right corner, get a little black cross or maybe a little target or something. Left click, hold it, drag down and release. So left click, hold it, drag all the way down and release. And there's our percentage changes every 5 years. Question, do we see a pattern? Look at these numbers carefully. Press pause if you want to think about it. What pattern are you seeing here? Is there a specific percentage change that we can say, oh, it's about a certain amount every 5 years? 20% or 30%. Is there a specific percentage we can say, oh, that's what it's going to be? Well, I don't see one. This is craziness. This is like all over the place, apart from the fact one thing is I can only see one negative. Right? So I see usually increases, but they're different sizes. Sometimes it's 67%. Sometimes it's only 5%. Sometimes a slight drop of 4%. But so for me, the trend is they're going up, but there's no particular percentage that you can say that it's definitely going to be 30% every 5 years or 20% or whatever, right? All right. So by golly, I can't really form a formula or anything based on this linear growth, and I can't form any type of formula based on these percentages. So what we're going to do is linear regression, right? So a lot of you're using slightly different versions of Excel, so I didn't want to make you have to find the buttons for the graph, but let me just show you that whatever version of Excel you're using, it is easy. You would just need to highlight these cells, okay? And then you would go to Insert, and then you would go to Charts, and then you would select something like that, okay? And then, I'll just put that up there, why not? And then to do the linear regression, okay? First of all, yeah, before we even do linear regression, I mean, just looking at that, what can we see? I just feel like what we can see is, golly, it almost looks like some sort of a pattern. Although when we add the table, notice that it was hard to find a pattern in this mess. Wasn't it? It's a mess, isn't it? I mean, we know we can see an increase, but we couldn't make out if there's some sort of average increase, right? But it seems like we might come up with some sort of a average increase if we work with the graph, because I mean that almost looks like it's hard to know, is it a straight line or is it a curve, right? What do you think? Yeah, I think almost either way you could probably model that with a straight line or with a exponential curve, either one. So I'm just going to do linear regression because that's pretty close for this data. So I'm going to click on one of the points. It highlights everything. I just right click. I add trend line. You already have this on your file, so you don't have to do this. I just want to show you how easy it is on Excel. So I just did that, and I'm going to say display the equation, display the correlation coefficient, and I'm going to go forward 20 years, 20 periods, okay, and just press enter, right? And that will give what you already have in your file, okay? So here's my here's my equation that goes with the trend line that we just made. Let's make that font bigger. Okay, so what's interesting about this trend line? Well, golly, it looks like the trend line is pretty close to the actual data that we graphed, right? And by the way, let me just explain what this correlation coefficient is. If this correlation coefficient is exactly 1, like the number 1, that means all of these filled in dots are exactly on the line. Okay, so in other words, if house prices went up by exactly $10,000 every 5 years, then this R squared would be exactly 1. It's a little bit off 1. It's actually 96%. It's pretty close. So that shows you pretty good linear correlation with this data. And this is the estimated trend line, the linear trend line. Okay, now if you remember from your equations, remember what's a linear equation? It's y equals mx plus b. Remember that? Y equals mx plus b, right? And what did the m represent? The m number, the coefficient of x, was the slope, right? And let's see what does that mean in this context? What does this 5717 number mean? Okay, so that's your little that's really key. I want you to try to figure that out. What does x represent? You have to think about what does y represent, and therefore what does this number represent. So if you press pause in the video if you like and just kind of think about that. Try to figure that one out. But I'm just going to go back and I want to go through our quantitative literacy skills here one at a time. Okay, so the first thing we done is we try to represent the data in an appropriate and accurate form. And what I want you to do is just think about, well, what did we do to represent the data? We were given a table, we were given numbers, we made a nice graph. Okay. And that, I think, it showed us, whoa, all of a sudden this mess of numbers is starting to make sense. We see a kind of a trend upward here, right? A nice, almost predictable trend, perhaps, right? And if you click on hide here, so right click on that and hit unhide, then the row 17 appears, and how did we represent data? We represented the table as a graph. Okay. Now next we've analyzed the data. We're making a judgment or drawing a conclusion about the data. Right. We're going to summarize observations of the data. Okay. So how could you? So press pause maybe or think about it. How would you conclude what we're seeing with this data? What are we seeing with this data? Like, what has happened so far with housing prices since 1965 to the year 2020? That's what I'm asking. I'm not really asking about the future in this. I'm just asking about what has happened so far. Assumptions is when we talk about the future or the past. We make predictions and estimations. Okay, but just what has happened so far? Okay, I hope you have a chance to think about that and perhaps press pause and think about it. But here's the answer I'm going to give. And if you hit unhide, it should show here. Okay, so the answer, I need unhide on, sorry, row 19 and 20. Okay, so we analyzed the data. We weren't able to see a clear linear or exponential, growth from the table alone. It was messy. It was hard to pinpoint a particular slope or a particular growth exponent, percentage growth rate, either one. And so but when we look at it and we've graphed it, and we're starting to see that what we can say though is that just looking at it, we can say that the median house prices have fluctuated on the short term, but they've usually risen, and they've risen definitely on the long term, right? Okay, and in fact, I would say if we can just figure this number out, that would be great. What does this number mean? 5717. And I'm just going to round that to. I'm just going to round that, by the way, to 5700, right? Because I just don't like dealing with that. And forget about this. This is just basically this is basically telling you what house prices would have been back in the year zero. If this trend line continues into the past. So that's the y-intercept. So ignore that number. It doesn't matter. But the 5700 means that X you see is years, Y is house prices, and it means that for every extra year, house prices have gone up by 5700 on average. That's per year. Now it's not every 5 years, okay? So like if I did, 5700 times 5, it's more like that. It's 28,500. So it's kind of like the average of these increases about 28,500. That's every 5 year period. But this means every year. So what's happened is median house prices have fluctuated on short term, risen on long term, and they've risen by about $5,700 per year, okay, on average. But of course, they do go up and down. They just usually go up, right? Okay, so and acknowledge limitations of the analysis we just did, right? So I'm going to unhide to get this row. And what's some limitations of analyzing this? Well, I mean, the fact that we're taking the kind of national average doesn't paint a clear picture, because different areas have totally different housing prices. Like San Francisco is different than New York, and that's different than Seattle, that's different than Aberdeen, Washington, that's different than Moclips and Montesano and everything else, right? So we're just analyzing the overall national median prices, national average, all right? So that's a limitation, right? Now, making assumptions about the data. What we're going to try to do is use estimation or modeling to make predictions. All right. So there's two ways we're doing this in Excel. One is we've got this trend line. So can you just give me an estimate for what housing prices would be by the year 2030? So it looks like a little over 350,000. So perhaps 360,000 by 2030. So what about median house prices by 2040? By 2040, a little over 400,000. So maybe 410, 420,000, something like that, right? And over here, we've got a little forecast calculator for you. So what I've done here is it's really simple. I'll show you how I did it. We just, on Excel, you can just go equals and just type in FORECAST, forecast, and then parenthesis. And then you're going to click here for whatever's in this cell. In this case, it's 2040. And then comma, and then we're just going to highlight all of the Y's. And then comma, and then we're going to highlight all the X's. And then close parenthesis, and then press enter. And 2040 to prediction is, the forecast is $415,000, right? And I can change this cell to maybe be 2030 if I want, and that'll say 357,000, right? Or I can change it to 2025, and it'll be 329. Oh, the same. Weird, right? Why is that? Why is it predicting house prices to be the same in 2025? Press pause if you want to think about it. I'll tell you the answer now. It's because house prices 2020 are more than average, more than the predictor line. And so it's predicting, gosh, they're probably going to drop down a bit, right? So anyway, let's put in 2035, and it looks like they might be around 386. Now, this is a very limited analysis, right? This is just based on these numbers here. So, and maybe this isn't even, the fact that we did linear analysis may not be appropriate. Maybe it is more like a bit of an exponential. So maybe that could have been a little bit more accurate. But yeah, it's good enough. It's close, I think. Might be good. Okay, so I'm going to hit unhide here to try to unhide here. Let's see. So we have row 24 and 25. So basically, this is what we've been talking about. Median house prices probably continuing to do in the future what they've always done, which is usually rise, but rise at sometimes a little bit, sometimes a lot. And our 5,700 number is here. Median house price may increase by about 6,000, or let's say, okay, just so we're not confused, I meant to say, well, what I was trying to say was 5,700, right? And then, as we calculated, maybe reach about 415 by 2040. Okay. Now, limitations of our assumptions on Hyde. So, future house prices are very hard to predict, right? There could be different interest rates from the Federal Reserve, which means different interest rates from banks, which means less people getting mortgages, which affects things. You could have a population growth or decay. You could have an older population overall can change things. There's property taxes to consider. There's social housing programs, like there could be affordable housing programs, which could change things. Who knows, right? All different reasons for house prices to change. And the other thing is, we didn't adjust for inflation because, maybe these prices aren't so bad. Like maybe these prices are, maybe a house in 1965 for 20,000 is the same thing as a house in 2020 for 330,000, right? So what we're going to do is adjust for inflation. And that is our next task. So let's see how these house prices are comparing to the economy overall, right?